Alright guys, so I want to record something for microscopy and how we calibrate microscopes, but it's not about the calibration of the microscope. It's basically how can you tell the size of an object or the subject on the slide. So that's what this CherNotes is about. So we have standard lenses, right? So there's objective lens and there is an ocular lens. So let's say at total magnification 40, then total magnification 100, then we have total magnification 400, and then we have total magnification 100, right? So there's some information that has been given to us where we can actually calculate it. So we want to find out the field of view of a particular total magnification. So let's say that something is given to us, and we know that for 100 total magnification, the field of view is 1.8. What is field of view? So when you look into the microscope, right, you look at your slide, right? Let's say slide is here, like this. And from here to here, your field of view is 1.8 millimeters. That's at a standard calibration. Let's say it's been given to us. So it's 1.8 millimeters. So it's going to take time for me to recalculate and look at 400 total magnification, 100 at 40. So there's a formula just because all of the field of view are proportional to one another. So the formula is diameter A, right? This is diameter, right? Diameter A, which is 1.8 multiplied by total magnification A, that's your A, divide by total magnification B. That's what you're looking for. So this diameter A multiplied by total magnification A is 1.8. Right, that's already included. So let's calculate that. So diameter A, 1.8 millimeters, multiply by total magnification, because this is at 100 total magnification, multiply by 100. You just move two decimals here. So that gives you 180. That gives you 180. That's what the information is. And now you're looking for total magnification B. What is total magnification B? Something that you're looking for, unknown. Let's say you're looking for 40. Let's do 40. 180 divided by 40, that is 4.5 millimeters. So the field of view, because you're looking for the field of view here, right? You're looking for the field of view. So the field of view for 40 now, 180 dividing by 40 gives you 4.5 millimeters. So the field of view at 40 would be 4.5 millimeters. Think. You have your field of view at 100, which is 1.8 millimeters. You can only see this much. But now your total magnification is less, but your field of view is wider. Because the further away you go from your specimen, the more you can observe. So now at total magnification 40, because you're far away now, you can see 4.5 millimeters. Now you can see more. Right? So if I would be looking or staring at that wall that is far away, I'm really far away. And I can observe a lot. But if I'm going to come closer, right, Now I can see less. But the subject would be bigger compared to, let's say this is the subject, right? That flask, let's say. So at 100 total magnification, I can see less, but the subject or the object that I'm looking at is going to be too big, right? It's going to be very big. But my field of view is so small. So when I decrease magnification, which is going away, my field of view becomes wider, wider, wider. I can observe not only that object, I can observe everything that is in my field of view. So when you increase magnification, your field of view becomes smaller. When you decrease magnification, your field of view becomes bigger. You can see more stuff. Same thing is here. At total magnification 100, you can only see 1.8 millimeters, but at your low magnification, this is the scanning lens, at 40, you can see more, but your field of view becomes wider, bigger. So now let's find out what's the field of view for 400. Now you're going to use a high power lens, so you're going to come very close to your object. So your field of view is going to be very small. Just because we use this formula, and that formula was calibrated at 100 total magnification, we're going to use the same number, 180, and total magnification B is 400. So now let's divide this by 400. We're just moving these decimals, and it's going to be here, 0.045. 0.45 millimeters. You increase your magnification, but you decrease your field of view. Now let's do the same thing for 100. Right? Total magnification 100. And that's going to be 0.18 millimeters. Right? So the field of view at this standard magnifications are this. They gave us this number. But what if you do not really know that? You can kind of ballparking, you can use a graticule. You can look through the microscope, right? You can use a ruler, there's a graticule, there's like a slide with like that, right? And the distance between each line would equal this, right? We can use this, but we can use a regular ruler like this, right? We can look at millimeters, put it under the microscope, and see where this lines lands, ballparking. So I look at the microscopes that we use, right? And what I saw at 40 total magnification, so when I use the regular ruler and I look at the field of view, I saw that 5 millimeters fitted under the 40 total magnification. 1, 2, 3, 4, 5, like that. 5 millimeters. But we know that it's 4.5, so it's approximately there because the lines on the microscope is very thick, right? That's a ballparking. I did the same thing for 100 total magnification, and my number came up to 2 millimeters, right? But it's 1.8. So we know that it's kind of precise. Obviously, to be 100% correct, 99.9, you must use this slide with a graticule where it's 0.1. Right? But we're right now ballparking, right? So the focus of all this lesson is not how to calibrate, but how to use this formula at different total magnifications. So now that we have all this information in millimeters, obviously in microscopy, you must multiply, well, you have to multiply by 1,000 micrometers, because everything is in micrometers. So then you take 4.5 multiplied by 1000, 1.8 multiplied by 1000, 0.45, and so on. So for example, if you're looking at something, 2 millimeters, right? It's easier to calculate. And the object takes half of that, and another object also takes half of that. Then you just take 2 divided by 2. So one would be 1 millimeter wide, and another would be 1 millimeter wide. If it, let's say 4 millimeters, right? You can fit 1, 2, and only 3. Then you take 4 divide by 3. Just because it's millimeters, you do have to multiply by 1000 to find it in the micrometers. Even though there are numbers and a lot of people are afraid numbers, me as well, I don't really like math. But once you understand how this formula functions, so everything should be pretty straightforward. Obviously, to properly calibrate microscope, you need to use this graticule with the proper information. So to use this ruler is just ballparking, but I killed a fruit fly today, fruit fly, and I put it under the microscope, and it actually almost took the field of view, right? So, and I was at 100 total magnification, so it was about 2 millimeters. So, and I ChatGPT'd it, and I asked what is the size of the fruit fly, and they told me it's about 2 millimeters. So, it's a very scientific method to find out your field of view. Take care.